here we're going to do question 5. Question 5 is a bit of a long one. What is the x vector that minimizes the following objective for these vectors? Now, you'll notice that we have a professor's note here, and we're going to follow this. So, for the derivative of this function, we need to find it first. And this is just the combination of the quadratic and a linear function. Now, we might need to remember that the derivative of the linear function f prime of x equals y, and that the derivative of the quadratic is f prime of x equals a plus a transpose x. Okay, so now that we have that in mind, we can just swap out these functions for the derivatives. So now we have let me just state this. So this is the linear, and this is the quadratic. So we're going to do a plus a transpose x. Sorry, that's wrong. There we go. Minus y. And this is the derivative. This is the derivative. So we're going to set this to 0, because if you remember from calculus, when the derivative is equal to 0, that is a local minimum or a maximum. And in this case, if you set the derivative to 0, that's most likely going to be a minimum for us. All right, so now we need to solve for x. We can multiply out a here, and a is a symmetric matrix. So we could technically say that this is 2ax, but we're just going to do 1, 2, 2, 8 plus 1, 2, 2, 8 is equal to, and we'll just multiply that by x here, minus y equals 0. We'll just do 2, 4, 4, 16, x minus y equals 0. Now x is a vector, and y is 2, 1, so I'm going to replace these. x1, x2, this is 2, 1. Now what we do here is I'm going to multiply these out, so we're going to get 2x1 plus 4x2 minus 2 equals 0. We're also going to get 4x1 plus 16x2 minus 1 equals 0. So now we have a system of equations here, and all we need to do is solve for the values of x1 and x2. You could use any form of system of equation solution that you like. I prefer Gauss-Jordan reduction, so that's what I'm going to do. So here, I'm just going to lay it out. 2, 4, 2, 4, 16, 1. I'm going to reduce these. This is a linear algebra technique, so if you haven't taken that, you may not be familiar with this, and I would suggest using substitution instead. So I'm going to reduce these. 1, 2, 1, 0. I think this is 8. And negative 3, which if we reduce these, 1, 0, 7 over 4, 0, 1, 3 over 8. And that gives us that x1, 7 over 4, and x2 is negative 3 over 8. So this was Gauss-Jordan reduction, which is a way to solve a system of equations, but you could also use substitution if you wanted to.